let us discuss the layers in the Iso-Osi model in detail. So first of all, we will be discussing about the lower layer called physical layer. So what is the role of physical layer means? Physical layer is responsible for the movement of individual bits from one hop to the next hop. Okay, so this is our physical layer. This is from the source and this is at the destination. So this physical layer is responsible for doing what? It is responsible for the movement of these individual bits from one node to another node. So the physical layer coordinates the functions which are required to transmit a bit stream over the given physical medium. It also deals with the mechanical and electrical specifications of the interface and the transmission medium. And the physical medium defines the procedures and functions that the physical devices and the interfaces have to perform for this transmission of the bits to occur. So the main functionality or the main responsibility of the physical layer is to transmit the individual bits from one node to the next node. The physical layer is responsible for doing the following functions. The first one is physical characteristics of the interface and media. It means the physical layer defines the characteristics of the interface between the devices and the transmission media. The second functionality is representation of bits. The physical layer data consists of stream of bits which is having sequence of zeros and ones without any interpretation. So to be transmitted, these bits must be encoded into signals which are electrical signals or optical signals. So the physical layer defines the type of representation, that is how these zeros and ones are being changed into the signals. The third functionality is data rate, which is nothing but the transmission rate. So what is the transmission rate? The number of bits sent per second, and it is also defined by the physical layer. So this transmission rate or data rate is also defined by the physical layer. So in other words, the physical layer defines the duration of a bit, that is how long a particular bit has to last. The last functionality is synchronization of bits. The sender and receiver not only must use the same bit rate, but also they must be synchronized with each other at the bit level. It means the sender clock and the receiver clock must be synchronized. So these are all the different functionalities of the physical layer. So now coming to the data link layer. The data link layer is responsible for moving the frames from one node to the next node. Do remember, in the physical layer we represent the data in the form of bits. In data link layer we represent the data in the form of a frames. Okay, so this is how you are going to represent a data link layer. Here in the data link layer, the data is represented in the form of a frame. A frame consists of header part, data part and trailer part. So this information at the source comes from the network layer, and this is the data link layer, and now this information is given to the physical layer, and at the destination the information is taken from the physical layer to the data link layer, and now from this data link layer again it is given to the network layer. Now let us see what actually data link layer is going to do. So this data link layer transforms the physical layer transmission facility, which is in the form of bits, okay, to a reliable link. So this data link layer makes the physical layer appear error free to the upper layers, which is nothing but the network layer. So let us discuss the major duties of the data link layer. The first duty is framing, that is the data link layer divides the stream of bits which is received from the network layer into manageable data units called frames. So this is nothing but framing. Second duty is physical addressing, that is if the frames are to be distributed to different systems on the network, the data link layer adds a header part to the frame, okay, to define the sender or to define the receiver of the given frame, okay. So if the frame is intended for a system which is outside the sender's network, then the receiver address is the address of the connecting device that connects the network to the next one. It means So let us say now this is the source, okay, this is the destination. Now this particular data link layer has to transfer the data which is out of this network. Then the receiver address of this particular frame will be the address of this particular physical node which is in between these two devices. Okay. The third duty is flow control. Flow control is nothing but, so if I am going to tell the explanation very fast, but you are unable to receive that information because my lecture delivering capability is very fast, but your understanding capability is very low. So here we need flow control, that is I have to understand with which capacity you are able to understand the lecture. So depending upon the receiver only, the sender has to send the data. So the data link layer here takes care about the flow control of the information. Okay, so it should not overwhelm the receiver. The next duty is error control. So the data link layer adds reliability to the physical layer by adding a mechanism to detect and retransmit the damaged frames or lost frames. Okay, so data link layer also uses a mechanism to prevent duplication of frames also. Okay, so error control is how it is achieved means it is normally achieved by adding a tailor to the end of this particular frame. The last duty of data link layer is access control. So whenever two or more devices are connected to the same link, the data link layer protocols are very much needed to determine which device has a control over that link at a given amount of time. So this is how the data link layer is going to work out. So here you can see how the hop to hop or node to node delivery happens in the data link layer. So this is our end system. So this is the link. This is our intermediate system. And again we have a link and we have an intermediate system and again the link and then the end system. So as we already discussed in the data link layer we have hop to hop delivery or node to node delivery. This is one node. This is another node. Now this is one node and this is another node. This is one node and this is another node. That is data is now going from now let us say the source is A and the destination is F. So now from A it is going to B, okay, again from B it is going to E, again from E it is going to F. So here the data is delivered hop to hop or node to node, A to B, B to E and E to F. So this is how the hop to hop delivery takes place in data link layer. Now the network layer. Network layer is responsible for the delivery of individual packets from the source host to destination host. Remember in data link layer we represented data in the form of frames, but in network layer we represent the data in the form of packets. So the network layer is responsible for source to destination delivery of a packet, possibly across multiple networks. So whenever you see the data link layer oversees the delivery of the packet between two systems on the same network. That is, the network layer ensures that each packet gets from its point of origin to the final destination. That is, network layer always is responsible for source to the destination delivery. So if you see in this diagram, the information is coming from the transport layer to the network layer. Here this complete H3 and data is completely given as packet. Okay, now it is going to the data link layer, and again at the destination data is received from the data link layer to the network layer in the form of packet, and again it is given to the transport layer. So one thing we have to remember is, if two systems are connected to the same link, then there is generally no need for the network layer. Okay, then we actually need only the data link layer, we do not need any network layer. But our real time situations are the two systems cannot be connected to the same link, because one system might be in one network and the other system might be in the another network. So for that reason, that is from source to destination delivery, we need compulsorily this particular network layer, because we cannot guarantee that the source and destination will be in the same link or within the same network. So if you see in this diagram, so this is our end system A and this is our end system F. So as you see, from this particular node to this particular node, which layer is responsible? Data link layer, which is hop to hop delivery, and from here to here again data link layer, from here to here again data link layer. But from source to destination delivery, which layer is responsible? this particular network layer is responsible. So this is how we represent the source to destination delivery using the network layer. So now there are some duties of this particular network layer. The first duty is logical addressing. The logical addressing is nothing but if this particular system F is in the same network, then we need only physical addressing wherein the data link layer is only sufficient. But as I told, the system is out of this particular system's network, so we need a unique way to address all the systems which are connected out of the network. So this is nothing but we are going to call it as logical addressing. The next most important functionality of the network layer is routing. That is, the network layer has to route the packets from the source to the destination in different routes. So it has to calculate the best route. So whichever is the best route to reach this particular destination and so on. So it has to calculate the different types of routes from source to destination. So routing mechanism is also very important factor in the network layer. The next layer is transport layer. The transport layer is responsible for the delivery of a message from one process to another process. If you remember, in the network layer, here it is responsible for delivering the information from source to destination delivery, but now coming to the transport layer, it is responsible for process to process delivery of information. Do remember, the network layer simply transmits the packets from source to destination, but it does not know about any relationship between those packets. That is, if those packets, whether they belong to the same message or whether they belong to the different message, it is not a consideration for the network layer. But coming to the transport layer, now this transport layer maintains the relationship between the packets which is being transferred from this particular source to destination. So if you see the figure, you get the information from the session layer. Now it is divided into segments and it is given to the network layer, and again from the network layer, again it is again divided into the segments and it is again given to the session layer. So this is how the transport layer is going to work. So if you see here, as we already told that the transport layer is responsible for process to process delivery of a message. See, this is our source node and this is our destination node. We have different types of processes in the source and different types of processes in the destination. Let us say now I am sending an email to you. So my Gmail process in my system must communicate to the Gmail process in your system. So for this reason I need the process to process communication. So for process to process communication or process to process information delivery, we need the transport layer. See here, we have communication between this node to this node. It is given by the host to host delivery, which is given by the network layer. Okay, that is source to destination delivery is given by the network layer, but process to process information delivery is given by the transport layer. So now let us see the different functionalities of transport layer. So the first duty of transport layer is port addressing. So generally computers run many processes in the systems. Okay, so for this reason I already told you, here we have many processes in this system, we have many processes in this system. So for each and every process we need an address to identify that one. So this address is nothing but it is called as a port address. So the transport layer is responsible for assigning the port addresses to the processes. The second duty is segmentation and reassembly. See, whenever it is receiving the information from the session layer in the source, it has to divide the data into the form of segments. Also, each segment contains a sequence number. So these sequence number enable the transport layer to reassemble the message correctly upon the arrival at the destination and to identify and to replace the packets that were lost in the transmission. So for this reason, segmentation and reassembly is also very important, and this is also one of the major duties. And the third duty is connection control. Connection between these two devices can be either connection oriented or connectionless. So in connection oriented transport protocol, before transferring the data, first of all it has to establish a connection, and after establishing that connection, the data will be transmitted. But in connectionless, the data will be transmitted without any connection, that is, the packets will be transferred from the source to destination without any order. It means the connectionless transport layer treats each segment as independent packets and it delivers these packets to the transport layer at the destination machine. So we will be seeing about the different transport protocols called TCP, which is connection oriented protocol, and UDP, which is user datagram protocol, which is connectionless protocol, and how do they work we will be seeing in the next classes. So the next functionality of transport layer is the flow control. So as we discussed that in the data link layer we need flow control, so in the transport layer also we need the flow control, but however the flow control in the transport layer, it is performed end to end rather than a single link. So here the flow control is performed from end to end rather than a single link as we discussed in the data link layer. And the next functionality is error control. So like in the data link layer, so the transport layer is also responsible for error control. So here also error control is done end to end rather than between the links. The next layer is session layer. So here as you see in the diagram, the information is received from the presentation layer, and now here we have a session layer and the information is given again to the transport layer. So mainly the session layer is responsible for dialogue control and synchronization. So dialogue control is nothing but, so this layer allows the communication between the two processes to take place in either half duplex mode or full duplex mode. And the next duty of this session layer is synchronization. So the session layer allows the processes to add checkpoints or synchronization points to the stream of data. That is, let us discuss this with an example. For example, if I am sending some 1000 pages to you, so it is better for me to add checkpoints at every 100 page. So let us say after sending 501 pages, okay, or 502 pages, now there is a problem in the system. So now what happens, as I already have a checkpoint at the 500th page, so there is no need for me to send all the pages which are previous to 500 page, or let us say there is a problem at 520th page, okay, as I already have a checkpoint at 500th page, I need not send all the pages prior to 500, so I only again restart from the 501th page. So this is how the session layer is going to help us by using synchronization mechanisms, that is by giving the concept of checkpoints. The presentation layer is responsible for translation, compression and encryption. So translation is nothing but different systems are going to use different encoding mechanisms. So the presentation layer is responsible for the interoperability between these different encoding methods. The next one is encryption. So to carry a sensitive information, so system must be able to ensure privacy, right? So encryption means the sender transforms the original message to another form and sends the resulting message over the network, and again at the receiver the decryption takes place. And the last one is compression. So data compression reduces the number of bits which are contained in the information. So data compression becomes very important in the transmission of multimedia data, which is nothing but text, audio and video. So this is how the presentation layer is going to work out. And the last and final layer in Iso-Osi model is application layer. So the application layer is responsible for providing the services to the user, that is, it enables the users, whether humans or softwares, to access the network. So this application layer provides user interface and support for services such as electronic mails, remote file access and transfer, access to the World Wide Web and so on for different types of applications. So the duties of the application layer involve the mail services, that is for email forwarding and storing, file transfer and access, the second one, and the third one is remote login, that is a user can log into a remote computer and access the resources of that particular computer and accessing the World Wide Web and whatnot. We are having different types of applications in the application layer. So this is all about the 7 layers in Iso-Osi model. So let us have the summary of all the layers. So physical layer to transmit the bits over the medium and to provide mechanical and electrical specifications. The data link layer, it is used to organize the bits into frame. Remember, in physical layer data is in the form of bits, in data link layer data is in the form of frames, and it provides hop to hop or node to node delivery. Network layer, it is used to move the packets from source to destination and it is used to provide internetworking and also routing. Transport layer, it is used to provide reliable process to process delivery of message and error control and flow control. In session layer, it is used to establish, manage and terminate the sessions and dialogue control. And presentation layer, it is used to translate, encrypt and compress the data. And in the application layer, it is used to allow the access to the all the network resources. So these are all the different types of layers available in the Iso-Osi model.